Hey there, grade nines. Welcome to today's lesson. We are going to get started with chapter 4. This one we're just going to talk about writing equations to describe patterns. So this is something that you might see kind of often. So for example, a pattern that you might see kind of regularly is if you're going out to eat, you've got a table and you'll be able to fit 4 people around it. But if you add another table, you would have kind of 2 tables and you would be able to add 2 more people. Right? So if you keep doing that, so you add another table, okay, so now you're up to 3 tables, you'd be able to add 2 more people. Here we had 4, here we had 6, here we had 8, and that pattern would kind of continue. Sorry, 8 here, not 6, okay? And that pattern would kind of continue as we go. So similar to this one, we're going to talk about kind of another example where we are going to look at the pattern and how we are actually going to create the equation out of it. So I'm just going to slide over a little bit. So here what we have is we have these plots. So imagine that you've got like a gardener and they're adding some square plots in the garden. So, but they're using wooden logs or sticks, okay? Or you're making squares with toothpicks, however you want to try to imagine this scenario. So when we have one plot, we have 1, 2, 3, 4 sticks. So we have 4 sticks. When we have 2 square plots, we have 1, 2, 3, 4, 5, 6, 7. Okay, when we have 3, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then here we have with 4 plots. Some of you might see the pattern already. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13. Okay? So what is technically happening when we're looking at this situation? Well, our number of plots is increasing by 1 each time. Okay? So this constantly goes up. Okay? So we could use P for plots, but then our boards that we actually have to use, these are increasing by 3. Okay? So every time we add a plot, we have to increase it by 3 more. Okay, so basically what we're saying is when we have 1 plot, there's 4 boards, but we're increasing by 3 every single time. So how would we come up with an equation for this? Right, so technically what we have, when we have kind of our input-output chart similar to this one, so our input would be how many plots we have, our output would be the total number of boards that we have, okay? Here what we're looking at is we're looking that it goes up, so there's an increase in the number of boards for every single time we add a plot, okay? So our variable is going to be our P, okay? So our variable is going to be P, and there's a couple of things that we need to do. So this kind of takes us back to grade 7. We talked about it a little bit. We're saying that every time this goes up, our output, our change in our output becomes our numerical coefficient. So our numerical coefficient is basically what we're multiplying our input by. So in this case, it goes up by 3 every single time. So we're going to say 3p, okay? However, that doesn't work out for every single situation. If we say 3 times 1, we would get 3, but our boards is 4. So what we actually do is we actually go back to where our input is 0. Okay, so when our input would be 0, what would our output be? Our output in this situation, so if we go back and we go back another 3, we would have positive 1. So positive 1 becomes our constant. So we have our numerical coefficient, 3, our variable, and then our constant becomes plus 1. Okay, so let's look at another scenario. So I'm going to slide over a little bit more. So here we're going to talk about kind of a word problem. Okay, so basically what's happening here is saying that you're flying in an airplane, and the airplane is at an altitude of 10,000 meters. Okay, it's starting to prepare to land. As it's coming down, every single minute, okay, it's able to drop a certain amount, okay? So basically what we're trying to find out is how far will it, or how long will it take for us to get to the ground? So that's kind of one possible scenario. But what would our equation be to try to figure out what that is? So when we're looking at this, our time, as we were talking about before, goes up by 1. And in this situation, our output, so our input is increasing by 1, our output goes down by 300. Okay? So it's different than our last scenario that we were looking at, but this one still works out. Okay? So because we are actually decreasing, we're actually probably going to have our constant first, because we're eventually trying to get to a point of 0. Okay? So we would have our constant first, so we would say 10,000. Okay? Because when we think about it, an airplane can't necessarily land, below the ground, right? So we want to make sure that we keep going until we get to 0, and we're not going to get a negative number. If we put our 10,000 first, that means we would have negative 10,000, right? Technically speaking, because we would probably be subtracting. So now let's see what we have going on. Okay, well, I'll explain that again, because we can do it another way. All right, so now we have it going down by 300. So 300 becomes what we would call our numerical coefficient, so minus 300t. Okay, so t is for time. So every minute it's dropping. So if we wanted to find out, what it might be at 15 minutes, we would put 15 in here. So we would say 10,000 minus 300 times 15, right? 300 times 15 is going to give us 4,500. So we're subtracting our 10,000 from that, which would give us at 5,500 meters above ground. So after 15 minutes, we would be we'd be about halfway to landing. Okay. The other scenario that I was going to say that we can do is we could actually say negative 300 t plus 10,000, because we started at positive 10,000. And we know that this is 10,000 at 0. Okay, so that becomes our numerical coefficient. For a lot of you, it might just be easier to see it reverse. So you're saying 10,000 minus 300t instead of negative 300. Now, let's look at this scenario, and we want to try to get our answer at 0. So we're trying to say 0. Okay, so how could we try to figure this out? Well, let's bring this one over to the other side. So we would have to basically add 300t to both sides. So we have 300t equals 10,000. Okay, I want to get t by itself, so I'm going to divide both sides by 300. Okay, so now I have t all alone. Okay, so 10,000 divided by 300 gives me 33.3 repeated minutes. So after about 33 minutes is when we will have landed from the beginning of the descent, right? So these are all the different some of the different scenarios that you might see. If you're able to see an input-output chart, the easiest thing to do is to try to track the change in the output. Okay, that'll become, once again, your numerical coefficient, so the one that's attached to your variable. And if it's a negative, okay, then it stays negative. Okay, in our previous example, it was a positive change. It increased by 3. Okay, and then our constant, once again, is when our input equals 0. That is going to be what our constant is. All right. If you have any questions, make sure that you bring those questions to the Zoom chat, or you can contact me through Google Hangouts. You can get started on your homework. Good luck.